Hi, my name is Evan Helmick, and this is my final presentation on alternative energy for ENGR 1023. I will be talking about some of the most promising alternative energies and new technologies in this area. The need for alternative energy comes from the issue of global warming. Global warming is one of the biggest threats facing the Earth today, and it's caused by the releasing of greenhouse gases into the atmosphere. Some of the effects we are already seeing today are an increase in surface temperature of almost 2 degrees Fahrenheit since the late 19th century. The ice caps are melting, causing the sea levels to rise, which has led to a decrease in natural habitat for many species and is leading to extreme natural weather events. It is also leading to the increased spread of diseases in animals and humans, like the Zika virus. All of this has led to now 1 million species facing extinction, and we could be next if we don't fix the problem. Even with all of this, some politicians are still trying to say global warming is not a serious problem. But all of this is being caused naturally, and humans aren't the real cause. Although there is no denying the fact that humans are releasing greenhouse gases into the atmosphere at an alarming rate. 37.1 gigatons of CO2 were released into the atmosphere in 2018, which is a record amount. The majority of these gases are being released by the burning of fossil fuels, which is mainly done for the use of energy in the form of electricity, heat, and transportation. This amount of CO2 is not going to decrease either. With the continued increase in population and the development of less industrialized countries becoming more energy dependent, everybody is using more energy every day. We need to change our habits and get the emissions to zero if we want to end global warming. The only way to do this is to find an alternative for energy creation other than fossil fuels. This has been very difficult because fossil fuels are so plentiful and they are very cheap around the world today. Solar power. The sun is the greatest source of energy known to man. If we can harness it correctly, it can be used as an unlimited source of pollution-free energy on Earth. The Earth receives more sunlight in one day than what is required to meet the energy demands of the world for 1 year. However, the technology is not yet ready to be commercialized and to power the world. The areas of improvement come down to a few things: the cost, the lifetime, and efficiency, as well as energy storage. Since the sun isn't always shining and some areas of the world don't get as much sunlight, we need to be able to store large amounts of energy to supply power in the nighttime or on a cloudy day, and battery power is just not yet strong enough to sustain full time with just solar cells. The new research in solar cells is being used in organic solar cells. These cells are revolutionary because they are much more practical than what is being used today, which is inorganic solar cells. They are easily integrated into products. They have a significantly lower cost to manufacture and are very thin and potentially flexible, so they can be placed onto curved surfaces like cars. The one issue is that organic solar cells are not yet as energy efficient as inorganic. What scientists are trying to work through right now is to find a material for organic solar cells that is highly energy efficient and thicker than typical materials used to make them easier to produce. One example is a thick ternary organic solar cell having a very high energy efficiency at 14.3% and 300 nanometers, which is 3 times thicker than the typical organic solar cell, making them much easier to produce. At 15% energy efficiency, organic solar cells could reduce electricity costs to less than 7 cents per kilowatt hour, while the current average cost in the US is 10 to 12 cents. This is huge because if solar cells are implemented on a large scale, it would be a cheaper option than fossil fuels. Wind power. Wind power is another promising natural resource that can provide unlimited pollution-free energy. Turbines restricted to just the non-forested, ice-free, and non-urban areas has the potential to supply over 40 times the current worldwide consumption of electricity. Wind power has been rapidly increasing in the United States in recent years. The amount of energy produced from wind went from 1% in 2007 to 6% in 2016. Though with increased population and more urban areas being created, there's not an unlimited supply of area to build these turbine farms. There's also an issue with creating more energy efficient wind turbines. The best way to increase energy output is increasing the diameter of the blade. There are, however, a lot of challenges that go along with this. The materials required in transporting these structures is very difficult, as well as it's being more costly to produce and to maintain. Turbines also create a wake, which can extend over 50 kilometers downwind, resulting in losses of several millions of dollars over multiple years. And similar to solar cells, it is not windy everywhere all the time, and energy storage will need to improve to supply energy full time to everybody. One way to counteract the space issue is that we can build offshore wind turbines to supply energy, but for large turbines, it's even harder to transport them for offshore turbines. A new style of turbine they are designing to counteract the increased costs and material transportation issues are multi-rotor turbines. Turbines with 4 rotors can cost about 15% less to build, even though the blades cover the same area. And if one rotor goes down, the turbines still produce energy. Studies show that multi-rotor wake intensity is smaller than classic turbines also. This is an exciting innovation that could be implemented wide-scale, improving wind turbines and making them a more large-scale energy source. Nuclear power. Nuclear power is a very controversial energy source that has unlimited potential. Currently, about 11% of the world's energy is produced from nuclear power plants, with some countries getting a high percentage of their electricity from nuclear power. In Ontario, Canada, 60% of electricity is generated from nuclear power, and in France, 72% is from nuclear. The downfalls of nuclear technology include the high costs from developing the technology and setting up the power plants, especially in high regulated countries. The current plants also produce a lot of nuclear waste, which cannot be used and just stored somewhere carefully. Also with safety, people have a hard time trusting anything nuclear. And the tech used in some of the new power plants is the same technology that can be used to create nuclear weapons, which this is obviously an issue that needs to be considered. If this technology was used on a large scale globally, then every militant country and most likely terrorist organizations would be able to figure out how to create nuclear weapons. This technology would have to be highly regulated by the rest of the world when it comes to dangerous rogue nations. Research in nuclear technology have led to the idea of breed and burn reactors. These reactors work like a candle burning down and runs on nuclear waste. These reactors eliminate waste completely as well as lowers costs of fuel. A company called TerraPower have been working and designing a power plant with this tech since 2007 and plan to place the first one in operation in 2026. The idea for TerraPower came from the thought of instead of burning the 1% of uranium, burning the other 99% as well, which was originally thought of as waste. This was never considered possible before, but now with the power of supercomputers being able to simulate these reactors, it shows that it is possible. There is currently enough leftover uranium in Kentucky to power the U.S. for hundreds of years. This means if the United States implemented these types of nuclear plants around the country, we would have a free energy fuel source that would last for hundreds of years and would be pollution free. Also, by filtering uranium from seawater, there is potential to have enough energy to supply the entire planet for the rest of its lifetime. This makes nuclear power the most viable source of sustainable energy, even with the dangers nuclear energy has too much potential, and to shy away from it would be stupid. Biofuels. Biofuels are made by converting created plants or microorganisms into fuels, commonly biodiesel. The first types of biofuels were created from food crops like corn, wheat, and maize. However, this takes a lot of area to grow the crops that takes away from the food supply. The most promising are algae biofuels, because they can grow rapidly and produce large amounts of fuel. Biofuels are being looked at so heavily because They are currently the only alternative to liquid transportation fuel and can be used in vehicles without a lot of engine modifications. But there are a lot of issues with the biofuel industry. Several companies like Shell and ExxonMobil that are abandoning their investments in environmentally friendly fuels. These companies making algal biofuels have struggled to retain high productivity at a large scale and have predators contaminate their farms. Building and maintaining these farms is very expensive, and the economics just don't make sense with oil prices dropping. There are also need to be a lot of consideration when choosing where to put the farms due to potential impacts on water stress at high water stress areas. Though there are a lot of issues, the biofuel industry is working on ways to help get the industry back on track and have success. People have found that algae can be made into other useful products like bioplastics and dietary supplements. Since these products can be sold for higher prices than biofuels, selling these products as well as biodiesel can help offset the high price of algae cultivation. Another way to save money is by placing these algae cultivation ponds near municipal water waste facilities. These facilities provide nutrients for the algae and can help save $1 million a year if within a mile of the algae ponds. These ideas could do a lot to help make algae cultivation cheaper, but until they find out how to make these ponds sustainable on a large scale over time, the industry is going to struggle. Looking into improving these, though, is probably a good idea since biofuel is the only alternative liquid fuel source. Unless we convert to completely electric cars and electric planes, this is going to be an issue. The last alternative energy technology I decided to study is hydrogen power. Hydrogen power is a promising source of renewable energy that emits zero emissions into the environment. Hydrogen is the most commonly occurring element on Earth and is found in water, which covers over 70% of the planet. The United States produces 100 billion cubic feet of hydrogen each year, and NASA has been using hydrogen technology for years on their rockets. Hydrogen as a fuel source can be used to produce energy through fuel cells as well as burning hydrogen fuel. Fuel cells are the most common source of hydrogen power. Fuel cells have a high conversion efficiency of 60% compared to fossil fuels, which are 34% efficient. They're also grid independent, making them very attractive for applications in places like hospitals and data centers. As you can see in the picture, they work by taking in hydrogen fuel, and the only byproducts are oxygen and water. Fuel cells are also being used for transportation in hydrogen-powered cars and buses. This is exciting since the only emission produced from these cars is water vapor. Honda, Hyundai, and Toyota have leased and sold more than 6,500 fuel cell vehicles in California, and many more companies plan to produce their own vehicles in the next couple of years. The issues with hydrogen power is the technology is not yet developed enough to make it cost effective on a large scale. The cost of fuel cell generation is 100 times that of a gasoline engine. There are a lot of requirements for the design membrane in a fuel cell, like excellent proton conductivity, chemical thermal stability, good mechanical strength, and low cost, to name a few. And none of the available membranes meet all of these requirements. Hydrogen could also be used in propulsion fuel for planes, but it produces large amounts of water vapor in the atmosphere, which contribute to net warming, which adds to global warming just as much as current fuels do. Although some of these challenges can be overcome, hydrogen power can be an efficient energy source for electricity. Hydrogen vehicles and fuel cell home heating systems have already been sold in many countries. Hydrogen-powered cars are the most similar alternative to gasoline-powered vehicles. They have a driving range of 300 miles and are more fuel efficient than regular cars, and they can refuel in minutes. This makes them very promising for public transportation. Hydrogen power has a lot of advantages, but like many other alternative energy sources, a lot more technology needs to be developed in order to make it a more realistic energy source that eliminates the use of fossil fuels. So that is my summary on many of the promising alternative energy technologies today. All of them are still in the process of being developed to the point that we can completely eliminate fossil fuels, but we are close. I don't think there's a single solution to this in our future, and many of these technologies will have to be used together to power the world to get the energy industry to the point where we exert zero carbon emissions into the atmosphere. Thank you.